Okay, students, welcome to your video on a better linear equations and inequalities review and a couple of quadratics applications, or also known as linear equations and quadratics potpourri. I thought these were cute images. No, I don't plan on getting this particular tattoo. That's insane, but it is kind of cool. So let's jump in and get this done because we can probably finish it in much less than our usual 15 minutes. Okay, so just a quick review of graphing a linear equation. Now, very seldom will it be given to you in this, ooh, hey, whoa, sorry about that. Very seldom will it be given to you in this format anymore. You're going to be asked to find it, to graph them in a different way. I am not going to be asking you to graph by finding solutions. I think that's a mistake. I would like you instead to graph with any method, and this particular equation we're going to graph by using y-intercept, -4. Right there at -4, I kind of exaggerated there, and slope, 2/3, so 2/3. So the change in y, remember delta is the Greek letter that's a triangle, it's change in y over change in x. So that means rise over run. So 2, 3, point. 2, 3, point. 2, 3, point. Go down, go the other direction. 2, 3, point. 2, 3, point. 2, 3, point. Put in your arrowheads, put in your line, graphed. So we remember how to do that. That's no problem. Let's look at it when it's not given to you in slope-intercept form. Okay, so we're going to use this one, -3x plus 7y. -3x plus 7y equals 21. What we're going to do is use x and y intercepts to graph. It's a really good method because it's a really simple, straightforward method. If you find the x-intercept and the y-intercept, and you plot them both, you can draw a line that passes through both of them, and you've got your line. So, x-intercept. If I want an x-intercept, how do I find it? Yes, that's right. You plug in 0 for y. So, I have -3x plus 0 equals 21 when I plug in the 0 for y, and x equals -7. X equals -7. So, the x-intercept is -7. There we go. Y-intercept, how do you find that? That's right, you plug in an x of 0. So that means we have -3 times 0, or 0, plus 7y equals 21, or y equals 3. And we plot that point right there. And then we go ahead and draw our line. We should be able to see our slope. Let's count it. Let's see, it's up 3 and over 7. So 3/7 is our slope. Okay, let me get rid of that real quick. All right, so 3, 7, right there will be another point, just to make sure I have a nice straight line, and there you go. So use your x and y intercepts when either the equation is not given to you in slope-intercept, this is standard form, or when slope-intercept form is going to be a pain in the butt to draw. In this case, it wouldn't have been bad, or not to draw, but to solve for. In this case, it wasn't bad, but this is just another method for graphing. Let's do another one. So now we're going into inequalities instead of equations. And we're going to look at these two inequalities, which are really, really similar, but not quite identical. So first thing we're going to do is graph the related line. So the related line equation for this is 2x minus 3y equals 6. So let's graph that. Go ahead and do so. Pause it, find your x and y intercepts like we just did on the previous problem, and then graph the line. Start by just plotting the points on both of the two graphs. I'm going to pause it and go ahead and do that myself. Alrighty. You can see here we have an x-intercept of 3 and a y-intercept of -2. So I plotted that, x-intercept of 3, y-intercept of -2, same thing on this one, and then I just continued the pattern up. But you notice I haven't drawn the lines yet. Let's talk about this. One of these two inequalities has a less than or equal to, and the other one has a greater than. Recall for me, when you had one variable inequalities, your less than and your greater than signs resulted in open circles on your graphs. But your or equal to's resulted in closed circles on your graphs. There is an analogy here with the two variable inequalities. You have a broken line, like a dashed line like that, and a solid line. Okay, that's the difference. So if this is example 2 over here, and this is example 3, this one is going to be a solid line because it's or equal to on that first one right here, and this one is going to be a broken line because it is not or equal to on the second one, right there. The shading portion of it, the easiest way to do that is to pick an ordered pair that is obvious. And the 0, 0 is the one I circled there. That's the origin. All you're going to do is plug that ordered pair in. If you get a true inequality at the end, then that's part of your solution set. Is 2 times 0 minus 3 times 0 less than or equal to 6? Yes. So that 0, 0 is part of my solution set. What about the next one? 2 times 0 minus 3 times 0. Is that greater than 6? No. Therefore, that is not part of my solution set. I'm going to want to get rid of that, and I'm going to shade the other direction. Now, if you were to have it set up where you have y is greater than or y is less than, so if it was y, for example, this one would be y is greater than or equal to 2/3 x minus 2. And this one would have been y is less than 2/3 x minus 2. See, in that case, you absolutely do have the inequality symbol showing you which way to shade. Up for this one and down for this one. But it's a lot harder up here when it isn't solved for y. And if it's not something we want to do, I wanted to give you a method you could use where you didn't have to solve for y. Excellent. Let's move forward. Now we're leaving the linear equations and inequalities and going to quadratics. Okay, so here you have a parabola. So we're switching gears altogether, no more lines, now we're in curves. We have a parabola, which has a quadratic function right here. And that quadratic function has zeros. And those zeros are right here, -3, right there, and +1. The graph of this parabola has those x-intercepts, so this is just a review here, guys, of -3 and 1. And I wanted you to see the relationship there. The x-intercepts are the zeros. If we think of this as an equation where we would take and make it 0 equals -x² minus 2x plus 3, the solutions would again be -3 and 1, and that's where we usually put it in one of these. And finally, a quadratic expression, which is just this side, has factors. In this case, those factors are x plus 3 and x minus 1, if we factor it. And what I did is I took out the negative. Let me do that real quick. Took out the negative sign, gave me x² plus 2x minus 3. Factors of -3 that add up to 2 would be +3 and -1. And that's how we get that factored form. But I want you to see the relationship all the way through. You have your factors, and you see your 3 and -1. Your solutions, -3 and +1. Also called zeros. Also called roots. Also called roots. Include that one in there too. And then finally, your x-intercepts, -3 and 1. So just wanted to kind of recap and bring that all together and show you how that's all related. All right, finally, finding the vertex from standard form. Let's go. Finding a parabola's vertex from standard form. Now, we could do completing the square with this, but I want to show you how you don't have to. Okay? The ordered pair, or excuse me, the axis of symmetry of your parabola can be found using the formula x equals the opposite of b over 2a. So the opposite of b here would be the opposite of -12 over 2 times a, which is 2. So the opposite of -12 would be +12. 12 over 4 is 3. Our axis of symmetry is x equals 3. So I now have my axis of symmetry and I want to find my vertex. You can take that and plug it in, find f of 3, and that's going to give you right there the y value of that vertex. That's going to give us that y value. So 2 times 3 squared minus 12 times 3 plus 1. All right, so 2 times 9, so 18, minus 36 plus 1, negative 36 plus 1, negative 17. Let me double check that. Yep, got it. So the vertex of this parabola is 3, negative 17, and I didn't have to complete the square to find it. And that covers what I wanted to get done today. So thank you very much. I hope this is nice and short. I think it is. And I will see you in class.